Okay, now students, let's do question number 4, and this is going to be the last question of the workout part. So as usual, just you need to subscribe to this channel because it's very important for you. So directly going to the question, you are asked to find the critical number, interval of increasing and decreasing, relative extreme values if any, and also interval of concave up and down and inflection point for this particular rational function. So in order to find all these, the primary thing that you need to do is you have to find the first derivative of this function first, and for this you need to apply quotient rule because it is a rational expression. So recalling that, let's see how we can find the critical number. So here it is. Your function f of x is 2x squared over x squared minus 1. So you are having a numerator 2x squared and the denominator x squared minus 1. So the derivative of this is going to be, first derivative the numerator, it will be 4x, as you see, because 2 comes down and the multiples 2, it will be 4x, and you will take x squared minus 1 as it is. Then using quotient rule, you do have a minus there, and then you will take 2x squared as it is, and you derive x squared minus 1. The derivative of x squared minus 1 is 2x again, as you see. Then you need to square the denominator, x squared minus 1 the whole squared. This is basically done using quotient rule, and the next one is simplifying this. So 4x times x squared makes 4x cubed, and 4x minus 1 makes 4x, and this makes minus 4x cubed divided by x squared minus 1 the whole squared. Here there are terms to be cancelled. 4x cubed can be cancelled by minus 4x cubed, and then you are going to obtain negative 4x divided by x squared minus 1 the whole squared. Look, 4x cubed can be cancelled by 4x cubed, and then you can have minus 4x over x squared minus 1 the whole squared. So the first derivative is now obtained. Now from this you can determine the critical number. The critical number, as you know, is a number in the domain of the function that makes your first derivative 0 or the first derivative doesn't exist. So in the case of this, the derivative gets 0 when 4x comes 0, when the numerator comes 0 here. So dividing the whole by negative 4 or 4, you will get x to be 0. So here 0 is an element of the domain of the function, because as you see, the domain of the function is the set of all real numbers except minus 1 and 1. So 0 belongs to the domain, so it is a critical number. So the only critical number we have here is 0. So look here, 1 and the minus 1, even though 1 and the minus 1 never define the derivative, they cannot be considered as easy critical numbers because 1 and minus 1 are not part of the domain. At the beginning they are excluded. So the only critical number we are having here is 0. Now proceeding to B, you are asked to find the interval of increasing and decreasing condition. So as you know, the interval of increasing happens on the interval containing x where the derivative is going to be positive. So we already have done the first derivative as you saw before. Look, this is the first derivative result. The denominator is always positive because it's the square of a certain expression. So in order to have a positive output, because the first derivative must be positive, this negative 4x must be positive, okay? Positive divided by positive, we can have a positive value. So minus 4x must be positive. For that, negative 4x must be greater than 0. And from this, since this one is negative, when you multiply the whole by negative, the greater than sign will automatically change to less than 1. And dividing the whole by 4, you see you can have x to be less than 0. So the interval of increasing is from minus infinity up to minus 1, union from minus 1 to 0. Basically it was less than 0, but we have to create a means of rejecting minus 1 because minus 1 is not part of the domain here. and because of that you see the interval of increasing is going to be this one. And when we directly go to interval of decreasing, we must have the case where the first derivative is going to be less than 0, and we directly come to this again because it's already done. The denominator is always positive, but our intention is to have a negative output because this must be less than 0. Negative must exist here. So in order to have negative here, since the denominator is positive, negative 4x must be negative. So negative 4x must be less than 0. So dividing the whole by negative 4, the inequality less than automatically changes to greater than sign. So x greater than 0 can come. So the interval of decreasing is going to be from 0 onward. But here again 1 must be rejected because 1 is not part of the domain. And because of that, 0, 1 union 1 to infinity is going to be the interval of decreasing condition. Now next from this we have relative extreme values, and the relative extreme values are nothing but those relative maximum and the relative minimum. So as you know, when you are having a shift from positive to negative around the critical number, you are going to have a relative maximum value, and from negative to positive shift at a certain critical number, you do have a local or relative minimum value. So here the case, minus 4x is here, and x squared minus 1 the whole squared is here. Your first derivative is also written here. So minus 4x gets 0 when x is 0. X squared minus 1 the whole square gets 0 when x is either minus 1 or positive 1. So as you see, minus 4x is going to be positive because you are going to use negative values from 0 to the left. So in the case of this you do have positive values, but in the case of this from 0 to infinity you are using positive numbers in place of x, and hence you do have negative outputs. But for this we always have positive values except at minus 1 and 1. So as you are dividing these two, you do have positive, negative divided by positive, negative divided by positive, negative values. Now we need to see the case where we can have the change of the signs around the critical number. The only critical number we are having here is 0, and at 0, as you see, sign is changing from positive to negative. So this shows you that there is a relative maximum value at 0. And we don't have a change from negative to positive. Because of this, we don't have any sort of local minimum value for this particular function. The sign changed from negative to positive at nowhere. Because of this, there is no local maximum value. And again, the sign changed from positive to negative at 0. As I said, at 0, at the critical number, the derivative changed from positive to negative. Because of this f at 0, your function was f of x to x squared over x squared minus 1. So f at 0 is going to be 0, right? So 0 is going to be our minimum value, right? 0 is our minimum value, our maximum value, sorry. So please try to have a certain correction here, make this to be minimum, right? It has been said here maximum, so please try to change this maximum one to minimum one, okay? Because here is our concern from negative to positive. In the case of this, we don't have any local minimum value, so make this to be minimum, and this one is right. So 0 is the local maximum one. Please have this correction. So f at 0, which actually 0 is our local maximum value, and we don't have any local minimum value. So far so good. Now comes the case of D, and that is the interval of concave up and concave down. And this is basically obtained by carrying out second derivative of the function. And we knew that the first derivative is this, so again applying quotient rule, the second derivative can be obtained. So as you are applying this second derivative using quotient rule, again the derivative of minus 4x is negative 4, and you will take this as it is, x squared minus 1 the whole squared. Now derivate the denominator, 2 comes down and 2x squared minus 1 can come, and when you derivate the inner one it will be 2x. and this negative 4x will be taken as it is as a multiplier, and then this must be squared. So as you are squaring this, you do have x squared minus 1 to the power of 4. And from this x squared minus 1 can be taken out, as you see, common, and can be simplified by this. Then you do have x squared minus 1 cube. So as you are taking 1x squared minus 1 out, you will left with 1x squared minus 1, as you see, but this is already taken out. So minus 2 into 2x minus 4x can come. So this is minus 4x squared plus 4. You can simplify this one, as you see, and this can come. Negative 4x squared can be cancelled by, here we are going to have negative 4x squared plus 4, and this is minus 2 times 2 is minus 4, with minus 4 positive 16. So 16x squared minus 4x squared makes positive 12x squared, and this negative 4 multiplied with negative 1 makes positive 4. So you will have this one. So now we need to identify the case where this second derivative is going to be positive and negative. So the interval of concave up is obtained when the second derivative is positive, and clearly the numerator is always positive, as you see. So we need to concentrate on the denominator alone, and as you know, x squared minus 1 comes positive if you are taking x values greater than 1 and less than minus 1. So clearly the graph of the function gets concave up within this interval, and when you come to the interval of concavity down, again the second derivative must be less than 0, and as I said, the numerator is always positive, and when you come to the denominator, your intention is to have the second derivative to be negative value. So this is attained when you are taking x values between minus 1 and 1, because as you are taking values between minus 1 and 1, the denominator is going to be negative. So negative numbers, the power of 3 is negative. In the numerator you are having positive divided by negative gets negative. So the interval of concave down will be from minus 1 up to 1. So what comes next is the inflection point, and the inflection point is a transition point from concave up to concave down and vice versa, and this is attained when the second derivative is going to be 0. So as we calculate, this is a case where the second derivative is going to be 0. What is going to come is the following one. Look, the second derivative is this one, 4 plus 12x squared into x squared minus 1 cube, and this gets 0 when the numerator is getting 0, but this can't happen because 4 plus 12x squared is always positive, whatever value you may take. As long as you are in the real number system, you see you are unable to obtain x value that can make this 0. And because of this, we do not have this this inflection point.